Hi, welcome to the Apple Radiology and Diagnostic session. My name is James. I'm the product manager from Advantech. AI can perform tasks that range from simple to complex, including everything from answering the phone to reviewing medical records. AI can also analyze population health trends, evaluate therapeutic drugs, read radiology image, make clinical diagnosis and treatment plans, and even talk with patients. AI has been applied to healthcare in the past, in applications such as diagnostic, image pathology, and sequencing. The major AI trend in diagnostics is to be used to detect cancer. Some studies also show that the AI system has achieved a detection accuracy comparable to a radiologist. AI can detect meaningful relationships in datasets and has been widely used in many clinical situations. The biggest advantage about applying AI in diagnostics is that it can be used to improve various fields of analysis, from gathering and processing valuable patient data to being used in AI-based treatment solutions. Let's take a closer look at how AI can be further used for medical purposes. First, faster detection disease. Applying AI to medical diagnosis provides many benefits to the evolution of healthcare industry. AI-based software can tell whether a patient has certain disease even before evident symptoms appear. AI can be trained to be better improve its detection of cancer, to be earlier and faster than experienced radiologists. Second, more precise diagnostics to classify disease. The opportunity of AI technology to analyze image and recognize patterns open up the potential for creating algorithms to help doctors diagnose specific disease more quickly. Moreover, such algorithms are able to continuously learn, thus improve its resulting quality of determining the right decisions. AI-driven software can be programmed to accurately spot signs of a certain disease in medical image, such as MRI, X-ray, and CT scans. Using such tools, doctors can diagnose patients more accurately and prescribe the most suitable treatment in a short-term time span. Third, personalized treatment. Even when the disease is detected and classified, the treatment process can cause additional issues. Not only can AI-driven software create a treatment plan that includes prescribing medicines and exercise, but can also coordinate care plans, help patients manage their treatment programs, and consider the risk of an adverse event. AI can help doctors arrange a comprehensive approach to disease management and provide a personalized treatment for a patient. Therefore, patients and caregivers can benefit from the application of AI in medical diagnostics. First, enhanced quality of care. For patients, the disease can be detected in early stage. Additionally, the personalized treatment can provide much potential to increase patients' lifespans. Machine learning can automate the complicated statistic work and help discover which characteristics indicate or not a patient will have a particular response to a particular treatment. The AI technique is thus a key technology to help people live longer. Second, improve productivity. For doctors, AI is improving the decision-making process. Diagnostic and treatment have always been complex processes. The doctor needs to simultaneously consider symptoms that the patient has, possible research mistakes, compatible treatment methods, potential side effects, disease with similar symptoms, and other additional concerns. Modern solutions based on AI technology have always helped doctors to overcome research difficulties, process big amounts of health data in short time spans, and ensure a full understanding of patients' health. Third, reduce the cost. For hospitals, accurately diagnosing disease takes years of medical training. In many fields, the demand for experts far exceeds the available supply. This puts doctors under strain and often delay life-saving patient diagnostics. Machine learning has recently made huge advances in automatically diagnosing disease, making diagnostics cheaper and more effective. To carry out these AI dreams, there must be a high-performance computer unit. USM is born for this task. USM enables doctors to apply AI technology to perform diagnostics, particularly in the field of medical imaging. One example of its application is an AI-based CT imaging. CT scanning is a medical image procedure that uses computer process combination of multiple X-ray measurements taken from different angles to produce cross-sectional image of specific area of a scanning object, allowing the user to see inside of the object without cutting into it. To enable the patients with more accurate diagnosis and prescribe the most suitable treatment, AI-driven solutions have the potential to provide high-quality and accurate diagnosis. With a combination of USM and NVIDIA GPU card, the diagnostic solution can fully deliver the need of AI-driven diagnostic solution and real-time image processing. AI engine should be able to function as a platform for image processing, quantitative analysis, and machine learning. To provide an accurate, efficient, and robust solution, AI engine should be supported by advanced algorithms and high-performance hardware, which are provided by NVIDIA and Advantech. Now we are happy to introduce our partner, NVIDIA, to share insight on how to implement AI on medical imaging.
Thank you, James. There are really three major trends accelerating medical imaging today. The first is that AI is coming at healthcare from all sides, with over 70% of imaging research involving artificial intelligence and hundreds of applications already approved by the FDA. The Internet of Medical Things is expanding, with medical devices at the edge evolving with more intelligent AI-powered capabilities. The need for compute at the edge, with solutions such as the USM 500, continues to increase as applications require real-time results and algorithms are deployed in more and more hospitals. We have built a complete platform to support AI applications in medical imaging. Our GPUs are available in many form factors to best fit specific workloads, from the Quadro RTX 6000 to the Tesla A100 and T4 to the small but mighty Jetson Nano. NVIDIA Clara is a healthcare application framework for AI-powered imaging, genomics, and for the development and deployment of smart sensors. It includes full-stack GPU-accelerated libraries, SDKs, and reference applications for developers, data scientists, and researchers. I'll dive into this a little bit more shortly. Our partnership with Advantech always allows customers to get started right away deploying medical imaging solutions with their GPU-capable products. Deep learning in medical imaging has shown great potential for disease detection, localization, and classification. It can improve the efficiency and effectiveness of a radiology team and allow clinicians to detect conditions that otherwise might have been overlooked. For this to happen, though, both data scientists and radiologists need to collaborate to develop high-quality AI algorithms. The NVIDIA Clara toolkit is available to anyone with a GPU and lowers the barrier to adoption of AI. There are tools to help with every step of the process, and I'll highlight four of them here: pre-trained models, AI-assisted annotation, and the training and deployment frameworks. We've made available pre-trained models for organ-based segmentation, classification, and annotation. Here you can see some examples of those models in action, performing liver and brain tumor segmentation. There are over a dozen pre-trained models available today, and we have even recently added one for chest CT for COVID-19 detection. Quality labeled data is absolutely crucial to train a successful deep learning model. The growing volume of clinical data in medical imaging slows down identification and analysis of specific features in an image. This reduces the annotation speed at which radiologists and imaging technicians capture, screen, and diagnose patient data. For labeling data, we've introduced AI-assisted annotation, which can integrate with the most popular medical viewers to make them AI capable and speed up the annotation process by up to 10x. As a result, radiologists can increase their productivity by analyzing more patient data while still using their existing workflows and familiar tools. In terms of the training framework, I'd like to concentrate specifically on federated learning, which many of our customers are very excited about and really opens up new possibilities within AI for medical research. Federated learning allows researchers to collaborate and build AI models across multiple institutions without having to share any private data. The training happens locally at each satellite institution, and only the partial model weights are shared with the host institution. Federated averaging is then applied to create a new global model. This allows researchers to train on a larger, more diverse set of data than was previously possible. And as we know how important data is to train these models, this really unlocks the ability to create more flexible and robust AI medical imaging models. Finally, once you've trained and are happy with your model, you're ready to deploy it. The deployment framework provides the tools that enable developers to optimize their models and easily integrate them with existing hospital systems. This enables end-to-end development and a scalable deployment. Here you can see an example of a multi-organ segmentation pipeline. First, the CUDA-based ROI generator splits a single volume into multiple regions of interest for lung, spleen, liver, and colon. These are then fed in parallel into different AI segmentation operators for each of those organs. Results from these AI operators are merged into a single volume and can be visualized in real time with the render service. All of this compute-intensive AI inferencing and rendering can be performed on a GPU such as the RTX 6000 in a USM 500. Now that we've quickly gone over what's part of the Clara application framework, let's dive into a couple examples of how the platform has been utilized. From medical institutions to research centers, developers, researchers, and radiologists are using the Clara platform to improve diagnostic and interventional imaging capabilities. Strokes impact nearly 800,000 people in the US alone each year. It's the fifth leading cause of death and the leading preventable cause of disability. A quick response time is vitally important as brain tissue continues to die as a stroke progresses. A typical patient loses almost 2 million neurons per minute a stroke is untreated. Immediate treatment is needed to minimize this brain damage. To help radiologists diagnose the most urgent cases and enhance critical care, the Ohio State University Department of Radiology used Clara with GPU-accelerated deep learning to develop an identification and notification system they called Actions. Training on GPUs took only 6 minutes versus 5.5 days with CPUs. Ohio State's solution returns results in seconds and identifies the most urgent cases of stroke, hydrocephalus, hemorrhage, and large tumors, with the associated compression of important adjacent structures. Actions has an 81% accuracy in detecting the most urgent stroke cases and a 91% accuracy rate in the other categories. With all 4 types of cases, the quicker the patient gets treatment, the better the outcome tends to be. The World Health Organization cites lung cancer as the most common cause of cancer deaths worldwide. CT scans help radiologists diagnose lung cancer, but it can take up to 15 to 20 minutes to scrutinize just one image. InfraVision's GPU-powered AI automates CT scan processing and creates a lung nodule diagnostic report in less than 30 seconds. This automation is helping radiologists reduce workloads and finalize diagnosis reports with confidence. And for patients, it means faster time to diagnosis. When using T4 GPUs for inference, InfraVision achieves speedups of over 4 times compared to CPUs.
To perform AI technique, USM 500 is the best solution. USM 500 is a medical-grade computer. It complies with the IEC 60601, supports up-to-Xeon CPU, and provides flexible configurations. Most importantly, it has 4 PCI slots and install a 500-watt power supply to support powerful NVIDIA graphics card up to RTX 6000. USM does not only support Windows OS, but it's also able to run multiple Linux OS. Also, USM is designed with a no-noise smart fan with antibacterial housing. It perfectly fits the hospital environment. USM now is widely adapted to different applications, such as surgical navigation system, video stream management, endoscopy imaging, and so on. Also, it has a longevity life cycle. With the advantage of high computing power and flexibility, NVIDIA's Clara is able to run smoothly and provide the best AI solution. However, the combination of Advantech USM and NVIDIA Clara can be used in more applications other than medical imaging. It can also contribute to the achievement of the smart hospital. By connecting all the sensors, the AI can help to ensure public safety, improve patient care, and enhance operational efficiency. In addition to the radiology and smart hospital idea, USM plus NVIDIA can also be used in the laboratory field. It delivers powerful acceleration to the analysis process of genomic data. It can help researchers better understand viral pandemics like COVID-19 at a faster rate. Therefore, humans are able to respond to the virus as early as we can, or even prevent an outbreak from happening. What do you think?
That's a great point, James. There are so many use cases and applications for USM and GPU in healthcare. Perhaps no data set in healthcare, or for that matter in the world, is growing faster than genomic sequence data. The cost to sequence a genome has dropped dramatically over the last couple of decades with next-gen sequencing, or NGS. Of course, with that decrease in cost has come an increase in the number of genomes that have been sequenced, roughly doubling every 7 months. This puts a huge analysis burden upon the genomics community. Estimates suggest that within a few years, using current approaches, trillions of CPU hours would be required just to keep up with the data coming off these instruments. Fortunately, the analysis required in genomics is very amenable to GPU computing, made possible by the USM. One of the goals of genome sequencing is to enable precision medicine, which is all about tailoring treatment to a specific individual. Keep in mind that the human genome is over 3 billion bases, which consist of the 4 nucleotides A, T, C, and G. And when we sequence one individual, that results in a data file of about 100 gigabytes. We then analyze this sequence first by mapping it to a reference sequence, then filtering out duplicates and misaligned reads, and finally we do variant calling, which means we are tagging individual bases that differ from that reference sequence. And that's just for one person. Many genomic studies involve the sequencing of hundreds, thousands, or hundreds of thousands of people. In order to perform this analysis in a timely manner, you need to use GPUs, and a platform like the USM is a perfect fit for a clinical or laboratory setting. To give a sense of the speed you can reach in genomics analysis in something like this platform, here are the findings of a peer-reviewed article on NVIDIA's Clara Parabricks software. That's our genomic analysis toolkit for GPUs. This recently published article compares an older version of Parabricks to GATK from the Broad Institute on a CPU. The results show that Parabricks is almost 40 times faster. Also, while other solutions yield diminishing returns with increased compute power, Parabricks speeds up linearly with the number of GPUs used. James, you also briefly mentioned smart hospitals, which is another great use case for the USM and GPUs. The delivery of healthcare is becoming more challenging as providers are having to do more with less resources. Smart sensors such as cameras and speakers can act as eyes and ears to ensure safety and operational excellence of healthcare facilities, as well as advanced care for patients. It's now possible with smart sensors to measure for fever or absence of protective gear, monitor crowds for safe social distancing, interact with high-risk patients, keeping both patients and staff safe and informed. We've actually built out a platform called Clara Guardian, which is an SDK for smart hospitals. The most prevalent use cases include body temperature screening, which is typically used at hospital and building entrances to detect elevated temperatures in anyone walking into the building. If someone has a fever, they can be screened by a nurse to determine if it's safe to let them walk around the hospital due to possible COVID difficulties. Cameras can also be used to detect if people are following COVID-19 social distancing requirements, as pictured here, and if there are groups congregating in hallways. Using AI for patient monitoring can free up a nurse's time by alerting them to anything going wrong in a patient's room or notifying them of any requests. With COVID, it also limits the exposure a nurse has by reducing the need to enter every patient room regularly. There are even AI algorithms that can accurately detect when a patient is about to fall and dispatch a nurse or staff member to the patient's location. Patient falls are one of the leading causes for extended stays in hospitals and can be very costly. Finally, surgery analytics and contactless controls are two more use cases in smart hospitals that are still evolving and show tremendous promise in streamlining the workflows of medical staff.
Thank you. Advantech is a leading medical device provider, and NVIDIA is the expert in image processing and algorithm development. NVIDIA's high-end graphic card, including RTX 6000, 5000, has been verified to be comparable to Advantech USM 500. The Clara also performs successfully under this platform. In addition to the AI applications, such as imaging, smart hospitals, and laboratory field that we mentioned earlier, we believe AI will be widely adapted in the near future. Now the two giants, Advantech and NVIDIA, are cooperating to make this AI dream come true. Thank you.